So lots of previous studies have shown that network noise becomes a really big bottleneck in cloud environments. And what we wanted to see in this work was, can we go deeper and see how different programming models for parallel programming, here we study an asynchronous and synchronous PGAS versions of code, and how they're affected by this when we move from the HPC cluster to the cloud. And performance in some ways is similar, but it is also different in other ways. For example, synchronous code is still slower than asynchronous code, but the magnitude of that speed up is a lot more in the cloud, and we'll see that soon. And the way we kind of go about doing this test is we use the Bale graph kernels, and we have versions that we have with OpenSHMEM and versions that have been written with the HClib-actor library. So the platform we use here is PACE, which is the research cluster at Georgia Tech, and we had a grant given to us by Microsoft. So we have Azure virtual machines that we spun up to do the cloud tests. And because we were mostly focusing on how the network affects performance, we mostly restricted ourselves to using single core machines. And the difference between the two platforms that we used, so PACE and Azure both had similar chips, but the kind of networking they used was quite different. So PACE has InfiniBand networking within its data center, while Azure had Ethernet networking in the kinds of virtual machines that we used, and with only a region-level locality guarantee about where the virtual machines that we allocated were going to be placed. And because we were kind of trying to understand how a generic cloud performance would look like, we avoided using specific optimizations provided by Azure, such as accelerated networking, where they remove some of the network layer virtualization, or HPC optimized virtual machine instances, which do have specialized interconnects.
Just from sort of the face of it, I would expect that InfiniBand will just make a huge difference over Ethernet, and everything else doesn't matter. Is that good intuition?
Yeah, it is. But we were also kind of seeing how, so we aren't comparing cloud and HPC directly. We're comparing how different programming models behave on both of these platforms. But yes, InfiniBand would be much faster.
Raw speed.
Yes, yeah, in terms of raw speed, yeah. Yeah, of course. And for the workloads, we used the Bale graph microkernels. And these, of course, cover a wide variety of irregular access patterns modeled on graph programs, histogram, index gather, triangle counting. I think a couple of the talks today already featured these kernels. And we had 3 implementations that we did these experiments with. The first one was an OpenSHMEM implementation, which used synchronous message passing. And the other 2 implementations both used the conveyors library. One was pure conveyors, and the other one was the HClib-actor library, which is built on top of containers. So the main takeaway is that the speed up that we got from using an asynchronous communication pattern was much, much higher on the cloud as compared to the PACE cluster. So I'm talking several orders of magnitude higher. Like on PACE, the speed up from using HClib was about 10 to 30 times, but on the cloud, it was close to 100 to 1,000 times faster. And the other observation is that because of the noise that is present in these data center networks in the cloud, the variability of the results was also really high. We did 5 runs for each of these observations, and we took the average of those. The charts have error bars, but like it was very, very high variability. So for example, the histogram kernel showed a 68-second difference between the fastest and slowest runs. So the key takeaway here was that the non-blocking communication was very important to be faster on the cloud, and the magnitude of this performance increase was also really, really high. One of the, like I mentioned, what we didn't do in this set of experiments was study how node locality affects performance. By default, on the cloud, there are very few knobs that you can adjust to have your virtual machines be placed close to each other. In Azure, for example, there is an option called proximity placement, in which they say they'll try to put them close to each other, but you don't have any real guarantees that, for example, they'll be on the same rack. So that's actually something that we are now studying. I will cover that in the next slide. And of course, there is the possibility of optimizing workloads by getting the high-speed interconnect VM on Azure as well. The main problem with trying to do that is if you have research credits from Microsoft, you still have to talk to Azure support each time to get an extra HPC optimized virtual machine. And accessibility right now is really hard. Maybe in the future that will change, but right now it's very easy to use their general purpose virtual machines, but it's hard to get access to anything special. And that is kind of why our current research focus is on improving the performance of the actor library on these general purpose virtual machines. And the approach that we're currently taking is profiling the logical topology in real time to get an idea of the noise in the network and the burstiness, and then tuning either the routing libraries 3-hop scheme or remote atomics based on these profiling data. And it's kind of the end of my talk.
The VMs are like region affinitized, but were they also inside a same availability zone?
Yeah.
Simple question. If you could go back to key takeaway point 1, I just couldn't quite tell what the color coding was supposed to be between what was orange and what was blue. Is it possible to read that here?
Oh, I'm sorry about that. So the orange is the speed up on the cloud, and the blue is speed up on the base cluster. And I just kind of read out the graph. So it says that's the number of nodes that we used. It goes from 2 to 16, and the y-axis is logarithmic. So on the left side we have it goes from 1 to 10,000, and on the right side it goes from 1 to 1,000. These are for different kernels from Bale.